spinner A has the numbers 2 and 10 on it. Spinner B has 4, 6, 10, and 20. On both spinners, each number is equally likely. Okay, so we're going to find the mean. Well, the mean for A, let's use A with the little line over. Okay, the little line over means mean, so we can use that. In general, we use X because we're talking about X in general, but here we have specifically spinner A, so let's use A with the little line over to mean the mean. 2 plus 10 is 12. 12 divided by 2. Our mean value is 6. So then if we did the mean absolute deviation, well, let's see, that would be the absolute value of 2 minus 6 plus the absolute value of 2 minus 10. 2 minus 10, 2 minus 6. Take each entry value, 10 minus 6. Take the entry value minus the mean. Okay, so maybe on the third time here, I'll do that correct. 2, so we get 4 plus 4 is 8. 8 divided by 2 is 4. And then our variance, similar, remember the abbreviation is that the small sigma, the lowercase sigma. Okay, well, 2 minus 6 is 4. We had that from before, so now we have 4 squared plus 4 squared over 2 is 16. So then our standard deviation is this, just the sigma without the square. We have the square root of 16 is 4. Okay, now in this particular one, it's just a coincidence that the mean absolute deviation and the standard deviation are the same. It's not a pattern that holds most of the time. It just happens to be a coincidence. Now, spinner B, and when you do these, you can shortcut them. You don't need to show adding all the numbers up, but I would like to see the totals. So for spinner B, 4 plus 6 is 10, plus another 10 makes 20, plus 20 makes 40. So we get a total of 40 divided by 4, which gives us 10. So then our mean absolute deviation, let's see, so we would do 4 minus 10 is negative 6, the absolute value would be 6. And then if we're looking at 6, that's 4 away from 10. And 10 is 0 away from 10. And 20 is 10 away from 10. So we end up with 20 divided by 4, which is 5. Okay, so if you can start to do some of these computation parts mentally, that's fine. Save yourself a little bit of. Now the nice thing is, Mason, if you square positive 9, what do you get? Positive 9 squared is what?
Oh, 81.
Negative 9 squared is?
81.
81. So when we found these absolute deviations, really we think of squaring those numbers and it'd be the same as if we did our deviations and square get positive. So we have those, so we get 36 plus 16 plus 0 plus 100 divided by 4. So just recognizing little things like that will speed up your computations quite a bit. 152 over 4, and you get, what do you end up with for the deviation there? I'm sorry, not this. 38. Okay, so we get the variance, the 38 variance is the sigma squared. Then our little sigma, well, we had sigma squared, now we have sigma, so we must be square root of 38. bit more than 6. 6.1. 640. Okay, so we have that. Now we're going to look at what happens where we have z as a random variable. Z is the sum of what we get on spinner A. It's the sum of spinner A plus spinner B. So we're going to spin A, look, get that number, spin B, get that number, and then add them together and see what the sum result is. Kind of like with the dice. We roll the dice and then you see what the sum is. Okay, so let's go ahead and find our mean for those. Just kind of as a review, one way we could do this with the polynomial to get all the results. We have, first spinner has 2 antennae, so we can take x squared plus x to the 10th. And this next one has 4, 6, 10, and 20 on it. So if we multiplied it out, we could look at the coefficients to count the frequency of each event, and our exponent would be the sum. Right here, if I distribute dx squared, we get x to the 6th plus x to the 8th plus x to the 12th plus x to the 22nd. Distributing that x to the 10th, we get x to the 14th, x to the 16th, x to the 20th, and x to the 30th. Okay, so on your quiz, this is what I meant by write a polynomial and expand it. Okay, so simplify it. You could look at the little boxes to get your outcomes, but that's not expanding the polynomial. So now we just find our mean. Let's see, we're doing z. So we use z with bar over it to stand for the mean of z. Let's see, so we have 6 plus 8 plus 12 plus 22 plus 14 plus 16 plus 20 plus 30. And we're dividing that by, there's 8 outcomes, 8 possible, 128. Okay, so 128 divided by 8, 16, and then our mean absolute deviation. So I'm just going to go through and start looking at how far away from 16 is each of our numbers. And they're not listed in from smallest to biggest, but that's fine, that doesn't matter. So 6 is 10 away, 8 is 8 away, 12 is 4 away from 16, 22 is 6 away, 14 is 2 away, 16 is 0 away, 20 is 4 away, and 30 is 14 away. So then we're going to divide by 8, so we're 8 terms. And we end up with 6, I believe. 48 divided by 8, 6. So we got our mean absolute deviation. Let's do variance. Okay, now variance, we could look at doing our 6 squared plus 8 squared plus 12 squared plus 22 squared. I'm sorry, no, wrong ones. We look at doing our distance away 10 squared plus 8 squared plus 4 squared plus 6 squared plus 2 squared plus 0 squared plus 4 squared plus 14 squared. Okay, all divided by 8. And when we do that, we end up with 432. 432 divided by 8. 54 square root of 54 would be between 7 and 8. Okay. So we spun A, we spun B, and added those results to get Z. Do you notice any patterns between our statistical measures for A and B and their connection to the statistical measures for Z? Okay, the mean was added, right? This is when, so we did, spinner A had a mean of 6, and spinner B had a mean of 10. Okay. This works when we're looking at adding the results to experiments. It's not saying we could take a sample of this group, of this class, and I could ask you the question, how many siblings do you have? And get the average. And then go next door, Mr. Osberg's room, and say, well, on average, how many siblings do you have? That wouldn't give me the average of the two classes combined. But if I looked at, okay, I'm gonna find the total of siblings for this class plus the siblings for that class, then we would get, or we could add the means, add the averages. Anything else we can add? Yeah, the variance, I mean, what's the title of your lesson? It's adding variances. Okay, the title lesson kind of gives it away. Okay, the variances are also ones that, okay, so we could have added the variances. Doesn't hold for the absolute deviation, that's why we found it, to show it doesn't hold. It doesn't hold for this standard deviation, but if we know the variance, we can figure out the standard deviation. So then here's your theorem 7.2. Z is a random variable defined by adding the result of independent random variables x and y. What's the independent random variables mean? What's the independent part? Tell me. Yeah, they don't rely on each other. So if Caden flips a coin and Carlton tosses a die, it doesn't matter what Caden gets. It's not going to impact what Carlton gets. The expected value or mean is the sum of the expected values for x and y. That's why we put the little bars over the x and y and z. That's the expected value or mean. And then the variance is the sum of the variances. The main idea is the sum of random variables defined is the sum of two other random variables. You can find the mean and the variance by adding